Good afternoon. In today's session, we have to study our fourth unit, that is the three-phase induction motor. In previous session, we have studied about the DC motors. Now we are supposed to study about the AC motors. There are two types of AC motor, single phase and three phase. In our syllabus, we are supposed to study about the three-phase induction motor. So, electromechanical machine which convert AC electrical energy into a mechanical energy. That device we can call as a AC motor. जैसे हमने देखा है कि डीसी मोटर, व्हाट वी आर सेइंग अबाउट द डीसी मोटर, वी आर सेइंग डीसी मोटर also work as a electromechanical energy converter. It means what? It can also convert electrical energy into mechanical or mechanical energy into a electrical. The same thing we can do by using the AC machine. So we can say AC machine also as a electromechanical energy converter, which can convert AC electrical energy into a mechanical energy. Three-phase induction motor are widely used in the industry and in the commercial applications. This type of motor does not require any starting device. That's why we can call three-phase induction motor as a self-starting induction motor. So in our syllabus, we are supposed to study about the three-phase. That is nothing but the self-starting induction motor because it is not required any starting device. There are different types of electrical motor available like DC motor, in which we have seen DC shunt motor, self-excited motor, separately excited motor. In that, what we have seen, we can use the brushes with the commutator. That's why we can say about the DC motor. It can be available with brush or it can be brushless. Then there is another type of electrical motor like a AC motor. It can also use as a electromechanical energy converter. Then again stepper motor, linear motor. Now here we are supposed to study about the AC motor. So here there are two types of AC motors available. There are two main types of AC motor. These are nothing but synchronous AC motor and asynchronous AC motor. So in our syllabus, we are supposed to study about the asynchronous AC motor. Synchronous means what? Synchronous motor will require the power supply to the stator as well as to the rotor. And what we have seen in the DC motor, we have seen DC motor will also require power supply to both rotor as well as the stator. But one type of AC motor, that is nothing but asynchronous AC motor, or we can say it is a asynchronous induction motor. That type of machine will not require power supply to the both. It means what? Here only induction motor will require power supply to the stator, and it will depend on the induction to generate the torque. Here rotor port will not require the power supply. So here firstly we will see how we can make asynchronous. It means what? Induction motor. There are two types, single phase and three phase induction motor. Firstly we will see about how we can use induction motor. So firstly we will see about the single phase induction motor. There are lots of applications of the induction motor over a DC motor because it is having low cost. It requires less maintenance. It is simple in construction. It is reliable. Its power factor is also good, and we can call induction motor as a self-starting because it is not depending on any other. That's why we can say it is having lots of advantages over the DC motor. So here we can see firstly how single phase induction motor will work. So we have seen how the DC motor will work, how we can give the power supply. After that, how the magnetic flux will generate according to the Faraday's law, then how we will decide the direction of the induced current according to the Fleming left-hand rule. So here we are supposed to study about the working principle of the single phase induction motor. So we know that for the working of any electrical motor, which will be electromechanical converter, whether it is a AC or a DC motor, we will require the two fluxes. It means what? We will require the two poles, north and south. The interaction of these two fluxes produce the required torque, which is the parameter for any motor to rotate. Because when we will give the power supply at that time, as the magnetic field will cut the conductor. At that time, according to the Faraday's law, magnetic flux will generate. And as the magnetic flux will generate on the field winding, which are located on the poles, at that time, what will happen? Torque will get introduced. And as torque will introduced, at that time, motor will start to rotate. So we will require how to derive the torque. So when we will give the single phase AC supply to the stator winding, to which to the single phase induction motor. At that time, the alternating current will start to flow through the stator, or we can say it will work as the main winding. And this alternating current will produces the flux. We can say this flux as the main flux. This main flux also links with the rotor conductor and will cut the rotor conductor. So here, if you see how it will work, you can see here. We are aware about the field winding, armature winding, how we will get the concept of winding, because when we are supposed to study about the electromechanical converter, that will be AC or a DC. What is happening? We are using stator and the rotor. In stator, what we are using? We are using the yoke, pole. In the rotor, we are using the windings. These are nothing but the armature winding. In the stator, we are using the field winding. So we are aware about how there will be the winding. If we are using the inductor, at that time, we will get the winding and it will start to rotate as we will give the power supply. So to obtain the torque, we will require that there will be some angle between these fluxes. I have shown here how this winding will rotate. As this will start, you can see here, this will rotate like this to the clockwise directions. So we can say here, start and run winding, which is displayed by, if you see here, there is an angle of the 90 degree. So to obtain the value of torque, we have seen, we will get the equation Fr sine theta, tau equal to, we have seen in the previous session when we are supposed to study about the working principle of the DC motor. At that time, we have seen how it is depending on that angle. So here, what we are saying, to obtain the torque, because we will require the value of torque to rotate that motor. So there will be some angle between these fluxes, and this will be achieved by the physical displacement plus the electrical angle, which will causes the phase shift. That is to the inductance between these windings. I have shown here when we will give the power supply at that time. That will be the AC, because we are supposed to study about the AC supply. So here, when we will give the power supply at that time, if that switch is closed, that winding will become perpendicular to the conductor, and what will happen there? Fluxes will introduce, and due to which that winding will start to rotate. So here I have shown that winding will be in the running condition. So these fluxes are not happening at the same instant in a time due to the difference in between the start and the run winding. Because if you see here, this is the start winding and this is the run winding. So here there will be some difference between the start and the run winding. And if you see the phase relations between the start and running winding currents for the split phase motor, that will be the single phase. I have shown here single phase. That's why I have taken, this is 180 degree, so many 90 90 I have taken here, because we are talking about the single phase. In our syllabus, we are supposed to study about the three phase. But firstly, we will understand how single phase will work. At that time, you will get how the three phase induction motor will supposed to work. So here we can see here the start and the run winding. Both are in phase. As it will increase, here will also increment in the flux. So here, the starting winding is normally made up of finer wire and with the fewer turns. Because we are saying winding we can make by using the inductor which will have the turn. So here we can say it will meet up with the fewer turns as compared to the run winding. And to increase the inductance, the running winding is deeper in the core. And as the running winding will have the less resistance as compared to the starting winding, there will be more amount of current will flow in the running winding as compared to the starting winding. So what we are saying about here, the most standard split switch motor will have the switch, and that switch will be used to remove the starting winding from circuit after it has run up to a 75% speed. It means what? When we are having the stator, when we are having the AC motor, in which when we will give the power supply, at that time that switch will become the closed. And if you see, run winding will have number of winding higher as compared to the start winding because it is in the running position. That's why we can say its speed will be about 75% higher as compared to the starting winding. So here, not all motor will have the switches. Some are designed to both winding in the circuit and some are designed to have both winding in the circuit and some are designed to leave both. It means what? There will be switch or there will not be switch with the winding. So if there is a switch in the single phase induction motor, at that time it will remove the starting winding from the circuit and it will increases to speed at 75% speed. So now we can see we are having, there are different types of single phase induction motor. Based on the starting method, single phase induction motor are classified into different types. How we are giving the supply to the single phase induction motor. There is a split phase induction motor, there is a shaded pole motor, there is a capacitor start motor, permanent capacitor run motor, capacitor start, capacitor run motor. There are different types of the single phase induction motor. So here what we are saying, single phase induction motor will also have the construction like a DC motor. So here it this type of motor will also consist of the two main parts. These are nothing but the stator core, stator frame, stator winding, and also there is another type that will be called as a rotor. So in stator, what we have seen in the DC machines, DC machine will also made up of stator and rotor. वहाँ पे भी क्या था? Main parts. There are also the two parts. So here we can say stator we can make by using the thin laminations of aluminium or a cast iron. So there also we have seen we can make the stator by using cast iron or a cast steel. But instead of cast iron, we are using the cast steel. Why? To reduces the hollow. It means what? Here instead of steel, cast iron, if we are using the cast steel, मतलब iron की जगह steel use कर रहे हो, तो what will happen? It will form the hollow cylinder and which will give a slot to get the air. So here we can see the outer covering. We can call as a yoke, like we are saying in the stator. After that, like we have seen in the DC machines. After that, what we can see here, we can use here stator. There will be the stator frame, there will be the stator core, and there will be the stator winding. So about the stator frame, we can say it is the outermost covering of the AC machine. It acts as a covering and it will also give the protection. It will give the mechanical strength to all the internal parts of the AC machine. The same we have seen in the DC motor. The same thing here will be the applicable. After that, what we are saying here, we are using the frame. That frame can be made up of die cast or the fabricated steel. The frame of three-phase induction motor should be very strong and it will require the air gap that will be very small, because if it is not at that time, it will give rise unbalanced to the magnetic pull, and its main function is to support the stator and the field winding. After that, what we can say here, after the stator frame, we are using the stator core. So we can say we can use the core to reduce the eddy current losses, like we have seen in the DC machine. What does mean by eddy current losses? If we are giving the power supply and if there is any mistake, we have done any wrong connections, we are not giving the power supply accurately, at that time there will be the flow of current. At that time, that unwanted current we can say as a eddy current. So we can say if we are using the core, which core? The stator core, which is inside the stator frame. At that time, what will happen? It will reduces the loss. Which loss? The eddy current losses. And this type is made up of the stamping. All the stamping are stamped together to form the cover, and stamping is nothing but which is made up of the silicon steel. If you see, it will also we can make by using the silicon steel to reduces the eddy current losses. After that, what we are using, we have seen in the DC machine, we are using the field winding. So it is also stator, or you can say field winding, or we can say the stator winding. So the slots on the stator core of three-phase induction motor carries three-phase winding, and if there is a single phase, it will have single phase winding. So these three-phase winding is supplied by three-phase supply, and if there is a single phase, we can give the single phase supply, and the three phase of the winding are connected either in. So if we are giving the single phase, we can give directly. But if we are giving the three phase, at that time there are two types to give the power supply. There is a delta or star. It means what? In our syllabus, we are supposed to study about the construction working principle of the three-phase induction motor. For that, we are supposed to study how the construction of the single-phase and three-phase induction motor. So when we are giving the power supply to the three-phase induction motor, at that time, these three phases of the winding we can connect in the star or the delta connections. Star means what? Which will look like a, where if, which will look like a star. मतलब कैसे? If there are the three phases, at that time one terminal of these three phases will connected commonly, and three we can give these three separately. मतलब हमारे पास थ्री वायर्स है, तो थ्री वायर्स को हम क्या करेंगे, तीनों का जो एक पॉइंट है, एक कनेक्शन है, तीनों का एक साइड वी कैन कनेक्ट कंबाइन, और तीनों हमारे पास तीनों वायर के रिमेनिंग जो नेक्स्ट वायर का जो साइड है इट इज रिमेनिंग, वी कैन गिव दिस सेपरेटली, सो इट विल लुक लाइक अ स्टार. Or we can give the delta connection. Delta how? If we are having the three phase supply at that time, फर्स्ट वायर का सेकेंड पॉइंट सेकेंड वायर के फर्स्ट को कनेक्ट करेंगे, सेकेंड का सेकेंड पॉइंट थर्ड के फर्स्ट को कनेक्ट करेंगे, थर्ड का सेकेंड पॉइंट फर्स्ट को कनेक्ट करेंगे. इट मीन्स व्हाट? इट विल लुक लाइक अ ट्रायंगल. So we are saying that connection as a delta in the electrical language. So we can say if we are supposed to give the three-phase supply at that time, three-phase winding will be connected in the star or the delta connection. So that winding will be wound on the stator of the three-phase induction motor. We can call this winding as a field winding also, or we can say it is working as a stator winding, and which will be connected with the three-phase supply. After that, what we are saying? After that, we are using the rotor. Rotor is nothing but armature winding. Field winding को हम क्या बोलते हैं? Field winding we are saying which will work as a stator. After that, we are supposed to see how the armature को हम क्या बोलते हैं? In DC machine we have seen it is the heart of the DC machine, and we are saying that as a rotor. So here we are supposed to study about the construction of the induction motor. Now we have seen the one part that is nothing but the stator winding, stator core, stator frame. Now we are supposed to study about this rotor. So what we are saying about the rotor? The rotor is the rotating part of the induction motor, which is placed in the concentric way at the center in the stator winding. So the rotor we can make by using the steel laminations, which is having slot with the rotor conductor. The slots are not exactly parallel to the axis. This arrangement will reduce the noise and which will avoid stalling of the motor. And if you see, this rotor will connect it to the mechanical load, to the shaft. It means what? When we will give the power supply and when that rotor part will rotate at that time. The load, that load, there are the different types: industrial load, domestic load, we have seen agriculture load. So we can say this rotor part will connect it to the electrical load, which we are connecting through shaft, and the rotor is mounted on the shaft using the bearing on each end. And if one end of it, no, one end of that shaft we kept longer than the other limb to drive the load. It means what? When we will give the power supply at that time, as the rotor will start, that load will also start to rotate. Whatever load you are connecting to the rotor, it will start to rotate. Again, what we have seen, we are putting the air gap. हमने देखा है कि when we are supposed to see the construction of the DC machine at that time, what we have seen, we are putting the air gap where on the armature winding. It means what? Rotor winding. For which purpose? To get the air. It means what? For the cooling purpose. Because when that motor will rotate, what will happen? Power dissipated, and that power will get dissipated in the form of heat. तो क्या होगा? Heat बहुत generate होगी. So here we are supposed to maintain that heat. We are supposed to reduce that heat. So we will require their air gap for the cooling purpose. So here we can say there will be the air gap exists between the stator and the rotor. And when we will give the power supply, due to the induction, that energy will transfer from stator to the rotor. And the generated torque forces the rotor and load will start to rotate. So regardless of the type of rotor, we can see the rotation will remain the same of the load, because when we will give the power supply at that time, we are connecting the load to the rotor, and when that rotor will start to rotate, that load will also start to rotate. So depending, there is no dependence. These are independently will start to rotate. It means what? When we are connecting the load to that rotor, regardless of the type of rotor, which type of rotor we are using here, the rotation remains the same in each case. And the rotor of three-phase induction motor are classified in different types like slip ring, or we can say as a phase wound rotor, squirrel gauge rotor. We will see one by one. Now we are supposed to see about these different types of the induction motor. These are nothing but split phase, capacitor start, permanent capacitor, capacitor start, capacitor run. Capacitor start है, again capacitor run है. So combinedly, capacitor start, capacitor run. Shaded pole motor. So here we can see the standard split phase induction motor. If you see practically, that induction motor will look like this. And if you see here, we are not using any capacity. This will depend on only induction, that is between the main winding and the auxiliary. Auxiliary, it means what? Which is rotating, the running condition. And we have seen when we are giving the power supply, and if that switch is not closed, we can say that winding as the start winding. And if that switch is closed, it means what? If we are making that motor as on condition, it means what? It will start to run, motor will start to rotate. So we can say that type of induction motor will only depend on the inductance between the main winding and the auxiliary winding. Auxiliary means what? Which is running. Main means armature, and auxiliary means the field winding. It will depend on the inductance between armature and the field winding for the whatever the single phase or the three phase induction motor. Now, single phase motor will have external starting capacitor. At that time, we can say that type of motor as the capacitor run motor. We can see this type of motor will look like this. If we are supposed to study about the speed, at that time the number of poles of the motor is defined as it is the number of poles on the run winding. It means what? The field winding which will rotate. On that, the number of pole of motor will depend. If we are having the 4-pole single phase induction motor, at that time, if it is having the 4 run winding and 4 start winding, at that time we can calculate n equal to 125 upon p. So here we are supposed to study about the permanently split capacitor motor. So here if you see, this is the main winding. Main means nothing but main means armature winding, and this is the field winding, auxiliary winding. So here the both winding will have the same impedance. R is nothing but the impedance, resistance. And the phase shift is only because of capacitor. If you see here, we are connecting the capacitor in between the main winding and the auxiliary winding. So here the phase shift will depend on the value of the capacitor. So here we can say capacitor motor are the most popular type of the single phase motor available in the industry. Capacitor start motor, which is having starting torque and which is having very good speed regulation. After that, capacitor start, capacitor run. That motor will have very higher starting torque as compared to the capacitor start motor, and which is having very good running torque due to the both winding in the circuit and also that motor is in the running condition. So here we are supposed to study about the three phase induction motor in our syllabus. So these are the contents we are supposed to study about the three phase induction motor. So here we are supposed to study about the construction, the rotating magnetic field, its working principle, slip and torque characteristics, power flow, starter, speed control method, and some applications of the three-phase induction motor. So here, what we are saying about the three-phase induction motor, we can see three-phase induction motor as a asynchronous motor. It is the most common and frequently encountered the AC machine available in the industry. If you see its construction, it is very simple. Its price is less as compared to the DC machine. It will require very low cost, and it is having easy maintenance. Its wide range of the power rating, it can give horsepower that will be higher up to the 10 megawatt, 10 raised to 3, 10 into 10 raised to 3 watt. Run essentially at constant speed from 0 to full load. High power and weight ratio connected to the DC motor. So these are some applications. Not applications, these are some advantages, some features over the DC motor, because it is very easy to use, it is having easy maintenance, its cost is less as compared to the DC machine. Its speed, its frequency dependent. So here we can see about the constructions of the AC machine. It can be the part of pump or fan, which is connected to the some other mechanical equipment such as winder, conveyor or mixer. I have shown just some examples. How we are using the AC motor. This is nothing but induction motor. So here we can see about the slip ring induction motor, which will look like this. So we can see the induction motor will also consist of the two parts. These are nothing but stator and the rotor. We can say the stator, which is available with the winding. That winding we can call as the field winding. And the squirrel cage rotor. This is nothing but, this is the armature winding, or we can say this is the main winding. A cut away view of the squirrel cage induction motor. If you see, this is the outer covering blue. We can say this as the stator frame. After that, if you see here the copper like structure, the copper, this structure, we can say this is as a stator core. Stator core. After that, if you see here, I have written the name on that diagram. This we can say as a stator winding. In that, we are using the rotationary part, armature winding. That is the rotor. We can put that rotor with the air dots. These things will be available for the cooling purpose, as well as air gap on the rotor. Also we are taking some air gap in between the stator and the rotor. If you see here, यहाँ पे थोड़ा air gap है. We are putting that air gap for the cooling purpose. Also we can use the fan. The same thing, we can use the fan to reduces the heat. It means what? We can use the fan for the cooling purpose. So this is the cutaway view for the squirrel cage induction motor. And if you see the axial view for the stator and rotor for the stamp ring induction motor, at that time we can say this we can say as the outer covering, yoke, the outer frame. After that, we are using the stator core. In that, on that stator core, we are putting the stator winding in the slots. After that, inside that, we are putting the rotor winding, or we can say we are putting the rotor winding, and in between the rotor winding and the stator winding, there is a air gap. Also, on the rotor winding, we are putting the air gap for the cooling purpose. So this is the construction diagram for the axial view of the stator and the rotor winding of the induction motor. If you see, this type of induction motor is having some applications, like it can be used in the fan, blower, printing machine, lattice, etc. And its construction is very simple. There are no brushes and slip ring. These require less maintenance. Now I am taking your attendance. If anyone is facing any issue, you can ask me. now here we are studying about the AC motor. In our syllabus, we are supposed to study about the three-phase. In that, we are supposed to study two types. These are nothing but the squirrel gauge induction motor and the slip ring induction motor. We will see one by one. I am only giving here introduction about the construction. These are nothing but axial, auxiliary winding and the main winding. Main winding is nothing but armature winding, and auxiliary we can say as the field winding. If you see, AC motor is having the construction which will look like a DC motor, but there is some differences and it is having lots of advantages over the induction motor, like its cost is low, its power factor is good, it is reliable, its maintenance is less as compared to the DC motor. Then the types of three-phase induction motor we will see in the next class. If anyone is facing any issue, you can ask me. Okay. So we can conclude our today's session. Thank you. You guys can leave now.